Well, I got cut off in the last video, so let's finish that out real quick here. Whenever we were talking about the square root of 24, this is an irrational number because it's not a perfect square. We can't think of two things that, something you could multiply to itself and get 24. So because of that, this is an irrational square root. Now, if you were to use your calculator to figure out what is the square root of 24, you would end up getting 4.898979486. It's a big long number. Now it said in here that we're going to round this to two decimal places. So if I round this to two decimal places, that would have to be 4.90 because the 8 would tell us to round our next digit up, which would in turn round our tenths spot up also. So I wanted to make sure and finish that out for you before we went on. Now, we can get really fancy with the roots. There's all kinds of things that go on here. But I want you to keep in mind that squaring and square rooting are opposite operations of each other. Okay, here we have a problem that says the square root of 8 squared. Now, just to verify that I'm telling you the truth, let's go ahead and let's work this out step by step. In order to work these one at a time, I would really need to take care of what's underneath the radical first. So if I were to square an 8, that would be 64. Now I would need to take the square root of that because we're not done. So then the square root of 64 would be 8. So do you see how that's working? Why squaring and square root are opposite of each other, and we would just end up with that number? It's very interesting. Now, I want to apply that same logic to this next problem, because if we were to just say, oh, well, squaring and square rooting and just knock each other out, so our answer would be negative 19, we would be incorrect. So let's see why. We have to do what's underneath the radical first because the radical acts almost like an order of operations in grouping symbols. So we would need to do what's underneath here first, which would be to say negative 19 squared. And negative 19 times negative 19 would be a positive 361. So see, because we squared, we don't have to worry about that negative anymore. And then when we take the square root of 361, our answer would be 19. Remember a couple of videos back we were talking about principal square roots? Principal square roots are the positive square root. Another way that you can look at it is that it would be what's underneath the radical, but we would take the absolute value of that to ensure that it would be positive. And the absolute value of negative 19 would be 19. Don't forget, the absolute value is distance from 0. So that's technically what's going on here. Now, when it's numbers, we don't really have to go through all of that because we can either work this one step at a time, or if we understand that when we square it will be positive, and then we take the square root of the positive number would be positive, then we're fine. Where it really comes into play is whenever we're dealing with variables, letters. So for instance, in this problem here, we have the square root of r squared. So yes, it's true that the square and the square root will undo each other, but we have to ensure that this variable will be positive, and the only way to ensure that is to take the absolute value. So technically our answer here must be the absolute value of r. Anytime we're taking the square root with a variable, we have to make sure and put the absolute value bars in there just to ensure positiveness.